Welcome to Universe Sandbox Squared, and we're going to take a look at maybe some unexpected things about the way moons move around planets. We saw with the planet Earth that the Earth and the moon don't look like they're in orbit around each other at all. They look like a couple of ducks flying in formation. You can't even tell that the moon orbits the Earth from the standpoint of the sun. Let's look at the planet Mars. Mars has a couple of small moons, Deimos and Phobos, and you can see their orbits plotted out there. Let's put those into motion and see what they look like from the sun's point of view. We're looking out at Mars. Although Mars will stay in the same spot in our field of view, we're not tracking Mars so much as we're tracking the sun, looking at Mars from the sun. And there is, with time sped up of course, the motions of Deimos and Phobos. Isn't it interesting where you can clearly see here that both of these moons are in orbit around Mars? There's a couple of reasons for that. One reason is because these moons are so close to Mars, even though Mars is only about the size of the moon, these are so close that they rotate quite quickly. Now we're showing that we can freeze Phobos and watch Mars and Deimos as if they were moving around a stationary Phobos. We can actually watch this from the point of view of any object in the solar system. And we are waiting. There we go. You see we have smoke trails on for these, so they leave a trail behind them so that you can see the snaky path of the objects behind. We'll see that in a minute. We've got Deimos frozen now, and we can see Mars and Phobos going around in a circle, and our computer has slowed down because it's got so much to process. It's processing hundreds and hundreds of objects in the solar system in real time. It's not bright enough just to calculate what you see. It also calculates everything you don't see. That'll slow it down sometimes. See the smoke trails as they cross. We're back centered on Mars now. Look at the high eccentricity of Deimos' orbit. And there are the crisscrossing smoke trails, as it were, of the two moons behind Mars. That cloud of stuff you see behind there are all the moons around Jupiter. Outer moons of Jupiter don't line up in any kind of a plane at all. They're just a cloud. We'll go to Jupiter next. And here's Jupiter, and you can see the cloud of moons around Jupiter as we get closer, but now we get inside the cloud. We can see that the inner Galilean moons, Io, Europa, Ganymede, and Callisto, are all coplanar. They're on a plane just about perfectly with Jupiter's equator. And we'll animate those and take a look at their trails as they orbit Jupiter on its path around the sun. This is just an amazing plot here. It's all flat, but we're going to see an incredible demonstration of harmonics. See how these loops line up on top of each other? That's the harmonic relationship between those moons that keeps them in their proper orbits. See little Almathea in the middle there. And there's another little moon closer than Io, which make very tight circles around Jupiter. Look how flat the plane of the orbits of Jupiter's inner moons is. There's those harmonic peaks again lining up. Now if you're looking with a pair of binoculars, these four moons here, Io, Europa, Ganymede, and Callisto, are the four you're going to see in your binoculars, or even a small telescope. It takes quite a large telescope to see any more than those four. These are describing a path like a spirograph, as flat as a sheet of paper. There's Almathea, Thebe in the middle, very close to Jupiter. Making a swirl pattern. Europa orbits Jupiter much quicker than our own moon, but you can see it is doing a little bit of the same flying in formation thing. Ganymede even more so, the curve is less pronounced. And Callisto, the furthest moon from Jupiter, makes the most interesting path. Let's go back and look at the path behind Jupiter. Amazing, turning on virtual smoke trails of the moons of Jupiter and looking at it as if we were stationary with respect to the sun and seeing what the orbits of the moon look like around Jupiter. Next planet, we'll pick Saturn. We're browsing for it now. There are also search functions that Universe Sandbox Squared has to let you find things without just browsing around the solar system. But you know what? It's fun to look at the solar system and from different angles. But here's our find thing. Now all the asteroids, lots of rocks, and then we get to Saturn. And now we are at Saturn. We can see why we didn't see it. We panned the wrong direction. Saturn also has a cloud of moons all around it. Saturn has something very interesting when you get in close to where all of the moons are coplanar. One of the coplanar moons is rotating the wrong direction, and we'll see if we can find out which one that is. Now, looked at from the down on the North Pole, the solar system rotates counterclockwise. The solar system rotates counterclockwise. The planets rotate around the sun counterclockwise. The sun turns on its axis counterclockwise. And most moons rotate around their planets in a counterclockwise direction. This is not a coincidence. So here we are, backed off from Saturn. We're not looking at the rings there. We're just looking at the moons. Some of these inner moons are shepherd moons that actually shepherd parts of the ring. Leaving the ring there would cause us not to be able to follow the moons very well. But notice another thing. These moons are not all coplanar. They're on different planes. What do we see way outside there on the left? It's a great big moon because it's bright, isn't it? Look at that. There's some of the other moons of Saturn, and these guys are going every which way, all kinds of different directions. They are not aligned at all. That's why we're looking at the inner moons. There's Titan right there. Look at that. Titan is probably the most famous moon of Saturn. We've landed a spacecraft on Titan. But Titan is a little bit of an odd egg. Look how far off the plane of the orbits of the other moons Titan is. Look at that. It's way out of whack there. There's another thing wrong with Titan. It's not wrong, it's just different. We don't insult moons. But if you watch Titan very carefully, what's Titan doing? Titan is rotating the opposite direction from all of the other moons in the inner part of Saturn. here. All these other ones, notice how they're all going counterclockwise, but Titan is rotating clockwise around the planet Saturn. It's roughly aligned with the inner moons that all rotate the correct direction, but Titan has what's called a retrograde orbit. It's actually orbiting Saturn in a clockwise manner when you look from above the North Pole of Saturn. And there you go, look at that. Look how far out of line Titan is with the orbits of the others. Lots of astronomers say this is evidence that Titan is a captured asteroid. If that's true, it would be a very, very strange bird because Titan has an atmosphere. We've landed a spacecraft on Titan and looked around. It's very cloudy, very wet. Let's go skip a planet and go to Neptune. We're skipping a planet purposely here. Using our finder chart here, asteroids, there's Saturn and Neptune. Oh, that's Uranus. Neptune is actually a different color than it. Neptune looks a little bit green through a telescope, not blue like that. Uranus looks blue. So there's Neptune. We're going to look at its inner moons. Let's animate these guys. Once we find the closest ones in, it'll all be orbiting in a single plane. We'll see what they look like. There you go. Triton on the outside. Maybe the only moon you've heard of. And if I remember properly, Triton may be orbiting in a retrograde orbit. Let's take a look here. Absolutely is. Triton is another retrograde orbit moon, and it's giant, it's big. And look at the other moons of Neptune. Inclined at an angle to the ecliptic, making intricate patterns as they are very close to the giant planet. And as such, they move very, very quickly. They orbit very quickly. Look at that. While Triton runs out there, orbiting in the opposite direction of all of the other moons. And, just like Titan on Saturn, it's not coplanar with the other moons. See that? It's climbing up through the plane of their orbits. And it'll come out on top when it comes to the left side of Neptune here. Its orbit is so slow that it describes a fairly straight path around the sun, while these other guys are whipping around Neptune very quickly, leaving a distinct swirling pattern. Let's try the planet Pluto. Pluto has a moon that we know about, and a couple others that are not quite so famous, but we'll take a look at them. Oh, don't go that way. Go the other way. Those are just rocks. Okay, keep going. There you go. Pluto. There's Charon right beside it. See how close in size Pluto and Charon are? Those are to scale. Well, we're going to look at 4 Plutonian moons here and see what kind of patterns they make. And this is going to be really surprising. Look at the tilt that the plane of those moons' orbits has with the ecliptic. It's about a 45-degree angle there. That's pretty interesting. Let's animate it. almost hypnotic the way I try to make this 1 day per second, but actually it comes down to about 2/10 of a day per second because of the computational demands of this program. But look at this. Pluto is such a tiny planet, and the moons are so far away in relation to the size of Pluto. They look like ducks flying in formation. It looks just like the moon and the Earth. We had to go all the way out to Pluto before we found something that looks like Earth. And here it is, the planet Pluto. Look at that. Now that's a flock of ducks. Now let me remind you, we're looking at a scale model of the solar system. All of the objects are moving and rotating at their real speeds, at their real locations. Look at that. That is just as expected as Earth and its moon, and it's 4 times more interesting. Look at that. Got 5 moons out there. There's Styx, Charon, Erebus, and Hydra. All around Pluto. Pluto being about the size of our own moon there. Watch the smoke trails behind. Have the Milky Way in the background. We're close enough to see the disk of Pluto pretty clearly. And Charon looks like a disk. Let's rotate around so we can see the center of the solar system, just to see how remote it is. There you go. There's the sun. The sun from Pluto is about the same size Venus is if you're looking out at the night sky from Earth. It's tiny, but it still illuminates the whole planet. Look at that. All the moons lined up on the far side of Pluto. But the most surprising thing of all is the planet Uranus. And we'll look at that next. Look at that. Gotta love it. That is totally unexpected. That is awesome. But let's go to the planet Uranus. Looking around. Come on. These are the positions of all the planets in the solar system right this instant, including the Tesla Roadster out there. See that? The Tesla Roadster, by the way, just crossed the orbit of Mars the other day. It's actually further away than Mars is right now. There's Uranus. And let's zoom in and take a look at it. Uranus, with all its inner moons. Now let's take a look at this thing. We're going to freeze Uranus. We're going to look at these moons. Then we're going to animate them with the smoke trails on and see what kind of patterns we got on Uranus. Everybody's looking for that corkscrew pattern, and we're finally going to see it with only one moon or one planet in the entire solar system, and that's Uranus. Why? Because Uranus is on its side. The orbital plane of its moon is at about 97 degrees to its orbital path. So there you go. Don't stop. And like the gas giants, it's got plenty of moons in close that really zip around fast. Titania on the outside there. Oberon on the outside. Not participating in the spiral pattern there, are they? Fascinating. Running at the speed of, say, 1/8 of a day per second. 1/8 of a solar, of an Earth day per second. Look at that. Titania and Umbriel, both having a conventional orbit, but Oberon, I don't know what you call that. Whether it's retrograde or what it is. Not quite sure. Look at that swirl pattern from Oberon. Just amazing. This is the most amazing planet. That's what we were all looking for from the very beginning, thinking we'd get it from Earth and the Moon. Didn't get any such thing. Thought we'd get it from Mars. That was in a single plane like a spirograph pattern. This is your helix pattern. That's really, really interesting. Looking at the inner solar system. Titania coming down from the bottom. Umbriel looping over the top.
Stop.
Neptune in the background. And that's it.